Hello, everybody. Alright, so I'm here with a word problem, an algebra word problem. Somewhat interesting. Alright, so there's two rainstorms, and they occurred in 1 week in a certain area. The first rainstorm lasted 25 hours, and the second lasted 40 hours, for a total rainfall of 1,600 milliliters. What was the rate of rainfall for each storm if the sum of the two rates was 55 milliliters per hour? Alright, so let's see what we've got. Alright, so let's label some things here. So we can say that S1 is equal to 25 hours, or storm 1 lasted 25 hours. So S2, storm 2, lasted 40 hours. Okay, so we have that information. Now, it said the problem stated that the total rainfall was 1,600 milliliters, so we can say that the quantity R1 will be the rainfall for the first storm in milliliters, plus R2, the rainfall for the second storm in milliliters, is equal to 1,600 milliliters. Okay, and now we can say the rate of rainfall for each of the storms. We have to define those, and then we have to add them. So now, what is a rate anyway? A rate is a quantity divided by time. It's a rate of change, like velocity is distance divided by time. Alright, so we have quantity 1, which is, well, R1 is, R1 we have divided by 25 hours, so that's the rainfall in milliliters for storm 1 divided by the time of storm 1, plus the rainfall in milliliters of storm 2 divided by the time of storm 2, so it's divided by 40 hours, and all that is equal to 55 milliliters per hour. Okay. Alright, so now we've got this main equation here, and it's an equation in two variables, R1 and R2, so we would like to have it in one variable so we can solve for it. Now, we can use this one here. If we subtract R2 from both sides, that gives us that R1 is equal to 1,600 milliliters minus R2. Okay, so now we can substitute that into the equation, into the main equation, so that we'll have an equation in R2 only. So that gives us 1,600 milliliters minus R2 divided by 25 hours plus R2 divided by 40 hours, and is equal to 55 milliliters per hour. So make sure you keep track of units and things like that. They're very important, especially in word problems. Okay, so now we can condense these two fractions together. So if we multiply across here, so now that's 1,600 times 40, and that is 64,000. So 64,000, and then we have the milliliters multiplied by hours still. We have to multiply the units just like we multiply numbers. And so that's minus, and we're distributing the 40 to the R2 also, the 40 hours to the R2. So it's minus 40H times R2. Okay, so, and this is all divided by the common, oh, sorry, I forgot. I did this part, I didn't do this part. So now this is plus 25 hours times R2. Alright, now divided by the common denominator, which is 25 hours times 40 hours, and that gives you 1,000 hours squared. Because like I said, we multiply the units also. Alright, so this is equal still to 55 milliliters per hour. Okay, so now we have to multiply both sides by 1,000 h squared, so that we can try to get rid of all these fractions here. Okay, so if we multiply this side, the left side, then we're just going to get the numerator here. So 64,000 milliliters times hours minus 40 hours times R2 plus 25 hours times R2, and that is equal to, alright, so 55 times 1,000 is 55,000, and then when we multiply here, we're going to have h squared. We're going to multiply by h squared, so an h cancels out there, and this h cancels here, so we're just going to have milliliters times 1h. Okay, so now we cleared that fraction, and we can now combine like terms. So we have h times R2 and h times R2 there, so that's 64,000 milliliters times hours, and so negative 40 plus 25 is 15, so it's negative 15, I should have said. 15 hours times R2. Alright, so we're almost done here. Well, at least with the first part. So that's milliliters times hours. So a lot of this is just, keeping track of all this stuff. Okay, so now, so we can solve for R2 in just a few steps. So if we add 15 HR2 to both sides, and then we subtract 55,000 milliliters times hours from both sides, so we get R2. Okay, so that would just give us, let's see, so 55,000, well, 64,000 minus 55,000 is 9,000. So I'm just going to put the R2 on this side. 15 h times R2 is equal to 9,000 milliliters times hours, because these were like terms here. Alright, so even though I pretty much added this quantity here to this side, I just kept on that side, but this is the same thing as if we kept the 15HR2 on that side, so that doesn't matter. So now we're going to divide both sides by 15h. Alright, so now this leaves us with R2 is equal to, now 9,000 divided by 15, that's 600, and these h's cancel here, the hours, so that leaves us with 600 milliliters. See, the units are very important, because see, now we're left with milliliters. Now we know we can plug that back into the other equation, and also they help you to think about your answer, about your work, and to see if it makes sense. Because if you didn't get milliliters, if you got like R2 is equal to 600h or something, or h squared, that doesn't make sense.